Hello guys, let's do chapter 4, and chapter 4 is also very short, very small. It should not take us very long. Okay, this chapter tries to give you a feeling and understanding for organic molecules. And when we talk about organic molecule, by definition, organic molecule is a molecule that have two carbons bound together or carbon and hydrogen bond together. And that's a definition of organic molecule. Or somewhere along the line, yes, you will see some examples here. And somewhere along the line, it has a hydrogen attached to it. Okay, so, and then of course, carbon is the backbone of life in planet Earth. Look at carbon right here, and they can be four different elements. Other elements can attach to it, or two of the same, or all four of them could be same, but all four of them could be different as well. But the way we talked about the balance of carbon in the past, that carbon can have four covalent bonds attached to it. Here's a definition of organic molecule, carbon to carbon atom or carbon to hydrogen. That's a definition of organic molecule. And vitalism, before they thought organic molecules, only Mother Nature can make it. But now we know by Stanley Miller experiment, he was the pioneer back in 1950s. He was a graduate student and he came up with that experiment. And he made organic molecules in a test tube. And after that, they said, okay, vitalism is not true anymore. Here is what Stanley Miller proposed, if I find my pen. So he heated up some water in a container and it created some vapor water just at the beginning of the earth. All was on the surface of the earth was water vapor. Clouds, if you would. There was no air. There was no oxygen, carbon dioxide, oxygen, nitrogen as air. Then he put these toxic gases to us right now, methane, ammonia, and a hydrogen gas in a vacuum container. Remember, the surface of the earth did not have any air. It was vacuum. It was just like a space empty right now. And then he passed electricity. Why electricity? Positive and negative electricity. So you know, the clouds that are formed right here, the clouds that he made up right here by vaporing water, what happens, some of the clouds are positively charged, some of them are negatively charged. Of course, that's very hard to create in a test tube settings. So he passed electricity through them. Okay. And then eventually he got some organic molecules. After he did all of that, he got some organic molecules, and then vitalism was over. Right here, carbon, as you see in the center, and four hydrogen bonds are attached to it. So that's an organic molecule, or carbon to carbon, and then of course hydrogen molecules attached to each other. That's organic molecule. The balance, as we talked about it in previous chapters, for hydrogen is 1. Hydrogen can take up one more electron to be happy, and that's all it can take. Hydrogen, 2 is a maximum. And then oxygen can take 2 more electrons because it already has 6. It can take 2 more electrons to be happy. Nitrogen can take 3 electrons right here, and then becomes perfect 8. Oxygen becomes perfect 6. Nitrogen becomes perfect 8. You can share 3 electrons maximum. And carbon, of course, it has 4 already, and it can share 4 more electrons. The valence of carbon is 4, and it can share 4 electrons. You remember quickly, let's go back to previous chapters, refresh your memory, that a carbon atom, it has 6 neutrons, so it has 6 electrons. 2 in the first shell, right here, and then 4 in the outer shell. So it has space for 4 more electrons. Nitrogen, it has 7. So 2 in the first shell and 5 in the second shell. And always first shell, if you would, gets 2 electrons. 2 electrons here, 2 electrons here, 2 electrons here. And then outer shell 5. So in order to become perfect 8, okay, the electrons is they can take up 3 electrons. Oxygen, it has 6. So 2 in the first shell, 4, oxygen is 8. Oxygen is 8, 2 in the first shell, and 6 in the second shell. So in order to have maximum of 8 electrons, it can take up to 2 electrons. Okay, carbon dioxide is not an organic molecule, not organic molecule because it does not have carbon to carbon or carbon to hydrogen bond. However, urea has only 1 carbon, just like same as carbon dioxide, but it does have hydrogen somewhere attached to it. It's not necessarily attached to this carbon, but it has a hydrogen somewhere. So we consider urea as organic molecule. And you will see later on ATP well, that's a different story, but the phosphates, when it separates, we call it inorganic phosphate because it's not attached to any organic molecule. Here they are all examples of organic molecules, and then you should, they can form a ring, they can be straight, they can be in a variety of ways. Here is a carbon skeleton, I think.
The carbon backbones of organic molecules may vary in length and in location of single and double bonds. Molecules may be straight or branched and may even contain rings of atoms.
See, it can be straight, branch, or rings. You have not seen any rings. Oh yeah, I'll show you some rings here. But you will see a lot of those later. Hydrocarbons are organic molecules consisting of only carbons and hydrogens, fats and carbohydrates. Proteins do not fall in these categories. Nitrogenous bases do not fall in these categories. But fat and carbohydrates, of course, you do have like a phospholipid, but still we consider as a fat. Anyhow, it's tough to have a definition that covers everything. And they release great amount of energy. You remember that carbohydrates, they release 4 kilocalories, and fats release 9 kilocalories, which we talked about that in previous chapters. Here's a long chain of carbons. Isomers, okay, that's something else we need to talk about, are compounds with the same molecular formula but different structure and properties, like fructose and glucose, galactose. These are all have 6 carbon, 12 hydrogen, 6 oxygen, but they are all different isomers, and you will see them in next chapter. I will talk about them in next chapter. They are isomers of each other. Structural isomers, they have different covalent arrangement of their atoms. Cis and trans isomers, it depends on the locations of the isomer and of the hydrogen atoms. You will see examples of it. And then enantiomers is, if they are like our hand, that is called enantiomers. Right here, so if you look at the structural isomers, this molecule has 1, 2, 3, 4, 5 carbons and hydrogens. Same molecule. This one is just a branch. And then cis and trans, as I talked about it, cis, when both of them are on the same side, right here, is called the same cis. It could be a hydrogen, it could be, and that's what they wrote on X. It could be anything else. And then when they are opposite of each other like this, then it's a trans. Okay, so that would be, I'm sorry, that would be a trans. That would be a trans, and this would be a cis. Okay, when they're on the same side, it doesn't matter up or down. And then of course, enantiomers is when they are like hand, the 2 molecules face each other, and they see. This is another animation.
3 types of isomers are Structural isomers, which differ in the covalent partnerships between their atoms. Geometric isomers, which vary in arrangement of atoms around a double bond. Enantiomers, or stereoisomers, which are molecules that are mirror images of each other, like left and right hands.
Okay, so this would be an example of a trans, and this would be a cis isomer. Okay. L-DOPA, again, I don't want to talk about it too much. Let's move on quickly. These are the chain of carbons, which they are, if you would, right here, this carbon has 1, 2, 3, 4 covalent bonds attached to it. And this carbon, they're all carbons on the corners. Remember, on the corners, they're all carbons. And then, for example, this carbon, they didn't draw the OH and H here. So anytime you see something, there are 2 covalent bonds here. So there's another one here, another one here. So this is estradiol, and that's a testosterone, 2 different the precursive is cholesterol, and we'll talk about that a little bit later on in the semester. This is a very, very important PowerPoint, you guys. The functional groups, make sure you know them. For the rest of semester, we do need them. This is the hydroxyl group, OH. When OH attaches to a rest of the molecule at one end, and usually they're called the functional end at one end, is hydroxyl group. Then you have carbonyl group. So you have a carbon and an oxygen like that. That's a carbonyl group. Then you have a carboxyl group, COOH, like acids, amino acids, fatty acids. We'll talk about them. So that would be, these are all acid end. Then you have amino group. You have a nitrogen, 2 hydrogen most likely, and the other end could be a carbon. It could be another hydrogen like here, but it has, they call it amino group. Sulfur-hydryl group, so this is sulfur right here, and hydrogen attached to it. Right here, you will see it. This is an amino acid, cysteine, and then you will see that. Then you have a phosphate group in the cell membrane. Right here is a phosphate and or ATP, and the last one is your methyl group. CH4 is a methyl. But at the end, when it attaches to another molecule, it loses one of the hydrogens, just like you saw here. Okay, this is it. Just like urea, when this breaks down, it becomes a DP, right? And it gives us energy. So this is adenosine. It has a nitrogenous base plus a sugar molecule. And then 3 phosphate attached to it, phosphate 1, 2, 3. And then when it loses its 1 phosphate, becomes ATP, and as a result, gives us energy right here. So you have adenosine, 3 phosphate attached to it. It loses 1 phosphate, and then, of course, it allows you to move your fingers. It allows you to move your head. It allows you to talk. And that's what's happening inside of your body. A TP becomes a DP plus PI, and then that breakage, right there, this formula is plus of I forgot the most important part, plus energy. Okay, that allows you to move. And then here is a vial of Stanley Miller that he used at the end of they took a picture of it and showed it to you for his experiment. All right, we are done with chapter 4. Chapter 5 is long, and then you will see a lot of things on chapter 5. All right, guys.